Fine. Gonna grab 83.
Alright, today we are looking at something that's called the derivative. So if we have a function and its graph, so function here, x and y, and we have its graph. So So there's its graph, and if we have a point on that graph here, point P, and we then have a line like this blue line here, and so that blue line is the tangent to the function, to fx. So the tangent to f of x at point P. Now, the other thing about a tangent is that it just touches once, but also the gradient of the tangent is equal to the gradient of the curve at that point. All right, so that's what we are working off. So if we then have another point and another point up here, for example, black. In the textbook they call it Q on the thing on the they're calling it point A, so we've got another point here. Then we can work out, put the line between P and Q, and then we could work out that gradient of that line. So, what am I getting at? Let's have a look at this over here. There we are. So, I've got the tangent at point P. There it is, that blue line. And the red line is the line that goes through those particular points. And you can see on the screen here that the gradients of them are not really, they're not the same. But if I move this point here, point A, point Q, closer to, so moving it down the curve closer to point P, now you can see that the gradient is getting closer to that blue one. And the more I bring it down, the closer it gets. So what we can do is we can use, because we can calculate the gradient between P and Q without too much difficulty, we can use that to help us find out what the gradient of this tangent is. And so that's what the derivative is about. All right, so how do we do that? Put that all the way up to here. So, what do we know? If point P here has an x coordinate x, so point P, its coordinates would be x and fx. And then we go a bit further over to here for point Q. And if I decide to, and this is what we do, is we say, all right, that bit that we're adding on here, we're going to call that h. So then this x value here would be x plus whatever that h was. Alright, so our coordinates of point Q would be x plus h, and then to get the y, we would put that into the function. Alright, so now if I have a look, and I put this on this video here, we can work out the gradient of P to Q. So the gradient of P to Q is rise over run. And as you can see by the graphic on the screen here, we've created our right angle triangle. This side here is our rise. This side here is our run. So on here, let's put it in red. Okay, so our rise is this bit. And this bit here, of course, is the difference in our y coordinates. So that length there, our rise, it's getting a bit messy, would be the y coordinate at that point, f of x plus h, minus the y coordinate of this point, point P, which is fx. And our run, well, that's how much our x has changed by, and our x has changed by h. Right, remember this is all about patterns. There's connection and it's about pattern. So we're looking at the pattern. All right, so where have I started with? I've started with the fact we like to know accurately the gradient of this tangent. How can we do that? Well, we can approximate it by choosing 2 points on the curve. Why do we choose points on the curve? Because we know what that function is and we can work out exactly what those points are. All right, so at the moment that's what we're doing. So the rise, if f of x plus h minus f of x over h. Now remember, before I changed this h and I made it smaller. Yep. So I made that smaller, and as I made h smaller, you can see that on the graphic, I'll make h smaller again. So here on the graphic we've got x equals 3 up to x equals 8, so that's our h of 5, so that's why that's called h. And so as I make that smaller, the gradient of that red line gets closer to the gradient of the tangent. All right, so what we can say, and this is where that we did yesterday, the limit. So as h is getting smaller, so as h goes towards 0, so this is our, so for the tangent, then the gradient of our tangent is the limit as h tends towards 0 of the gradient between P and Q. Does that make sense? Again, looking at the graphic, we'll start with h5. As h gets smaller, going to 0, the gradient of that red line and the gradient of the blue line get closer and closer and closer. All right, point 1. Then when it's 0, disappears. If I go into negative, it's now less than that. So as h tends to 0, the gradient of our line PQ, because that point's coming down, 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 closer to there, the gradient of that red light as h, this here, gets smaller, becomes the gradient of the tangent. All right, so if we put the gradient of P to Q, which is this bit, in there, then we get the gradient of the tangent is the limit as h tends to 0 of f of x plus h minus f of x all over h. Alright. Now mathematicians give that give this here another name, and that name that they call this is the derivative. So this bit here, which I'm going to put my blue circle around, this bit here is called the derivative of fx, and it's written as f dashed x. All right, before we go any further, anything that needs clarifying?
Yeah. What does it say? Tangent M.
So for the tangent, m, the gradient of the tangent,
Yeah, but like, what's that letter next to it?
t. T for tangent.
Oh,
So the gradient of the tangent is the limit as h tends to 0, the gradient of this line PQ. So as my h gets smaller, this point comes down, 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 and so the gradient of that line gets closer to the
are we
tangent.
trying to find the line between P and Q?
What we're trying to find is the gradient of this blue line.
Wait, I thought we were trying to find the gradient of the red line.
Same.
We're using the gradient of the lead line.
Gradient of the red line to find the gradient of the blue line.
Very good. So we're finding the gradient of the red line,
But if we have no
and then
points-
we're using the gradient of the red line to find the blue one.
So, there is this. This here, is this the gradient of this?
This here is the gradient of our red line.
Yeah.
So then when we make this h smaller, that point comes closer and closer and closer.
Okay.
And so that gradient there of the red line comes around closer and closer and closer to the blue.
So we're finding the gradient of the red line to then use the red line to find the blue line.
Correct.
How, if we've got no points, how do we do that?
We do have points because we will know what.
I don't understand.
Oh, so we will know those points, but you're just putting it in that
I don't
form.
understand it.
Correct. We will know those points.
Native language.
Okay, because that's what's screwed.
Have you done this in Sweden?
Right. We will know the points.
I don't think I know that.
So let's look at
Good decision.
an example then.
I'll not rub that off yet.
That's a good idea.
All right, I won't rub that off yet. We'll leave it.
Thank you.
What's that thing?
What thing? Which thing?
Called the derivative of.
fx. So it's,
But then
so this bit here.
it
of
has
an
a
off-
little dashy thing on the end.
Yeah, it has a little dash. F dashed x,
Oh, okay.
and the dash means it's the derivative.
Oh, okay, cool.
So f is the function, f dash is the derivative.
Is it XPW?
xpw, where are we?
Blue. Next to the P.
Is here.
No, that's the F of X.
F of x, yeah.
Yeah,
It's messy, but it's f of x.
X. Is it X comma?
So MT means the gradient of the tangent.
The gradient of the tangent.
I love those.
Yeah, I should know.
I don't know how to do it. That's your way.
Right, can I rub that off yet? Yes, no, no, all right, I'm holding on.
Racism, culture. Probably.
Okay.
Right, can I rub it off? Yes, no?
Yeah.
Sure.
All right, so let's look at an example. I'm going to leave that bit there for just a moment. I'll refer to it.
Do we know why Jen and Kate are at the office?
Got no idea. None whatsoever.
Yeah, nice one.
All right, so example.
Still want them too. Yeah, you get ragged.
You know, I ain't got the same percent I got, so
You guys are so fucked, you're actually
Why is
screwed.
it
If you just miss the example, you're going to die.
have you got it written down?
I watched the whole
It's
example. and I
okay, it's on video.
We didn't understand it when you read it down.
It's on video.
Where does
It's
it
say
It's on video.
It's on video. See,
Oh, you're recording it.
yes,
Maybe
Are
we
you
should
recording
record
it?
yes.
I said why?
So you can watch it.
Because it's
You're
so
gonna get wrecked if you don't.
A few people away on call for schools.
True call for schools stuff.
So I'm going to.
So he's recording it. So she doesn't have to explain it again. Because that just takes way too much effort. Yeah. Where will this video be located?
Yeah, I'll put a link on today's compass.
That will be useful. So is that just saying by first finding the red line?
Yep.
Okay.
Yep. So we're going to find the gradient of the red line, this one,
Yeah.
and then use that.
Oh,
Find
is
out.
it the gradient of the red line?
So yes, this one here's the gradient of the red line, and the one underneath it is the gradient of that blue line.
Trust me, I'll look at this book in about 10 minutes and be like,
All right, I'll do a rough sketch of this. So x squared minus 2x will have intercepts at 0 and 2.
I
Goes
give
like that.
myself enough room for this example.
So it's not.
Oh no, so doesn't it keep going?
Oh yes, it does. I just didn't like the way I drew it. Just want it a bit wider. It's going to make it easy. Doesn't matter, but it's just going to make it easier. So that's point X. That's point P, and that one over there is point Q.
Be faithful. It's don't understand.
How do we know where to put P and Q?
In this case, we don't. Sometimes we might be given an X value,
So we can just chuck it over and move it.
so we just put it anywhere just for convenience. All right. So, the distance between these two is always going to be h. So we're always going to use the run as h. So point P has coordinates x and f of x. Now, our function, of course, is x squared minus 2x. All right, so that's our point P. Our point Q has coordinates x plus h and f of x plus h. Now, of course, what that actually means is to put x plus h in our x squared minus 2x, and if we do that, we have x plus h squared minus 2 times x plus h. All right, so our gradient of our red line, let me draw it in. PQ is the rise over the run, which is f of x plus h minus f of x all over h. So let me just rub that out and put in what we've got. So f of x plus h is this one here. So we've got x plus h squared minus 2 lots of x plus h. And from that, we're taking away our f of x, which is this one. So we'll take away all over h.
Does that have to be in brackets, x plus h squared?
Oh yeah, it does. Thank you. Right, let's get rid of this. All right, now we've got to expand all that stuff. It's just a bit of messy algebra, it's nothing difficult, and when you do that, you get x squared plus 2xh plus h squared minus 2x plus, sorry, not plus, minus 2h, then minus x squared plus 2x all over h. Now, what do you notice on that top line there? It's a lot of x's. It's long. You can't simplify it because you've got an x squared and you take an x squared. You got minus 2x and you're adding 2x. So what have we got? We've got an h squared term. We've got a 2xh term. And we've got a minus 2h term all over h. What do you notice about that?
Cancel out some h's.
You can cancel out some h's. Well done. Take h out as a common factor. Equals h plus 2x minus 2. A lot of mucking around there. Right, it's only a lot of mucking around. Just a bunch of algebra. Right, so first considering the gradient of the line PQ. Well, this is our gradient of our line PQ. It says find the gradient of the tangent to the curve. So the relationship between the gradient of the tangent and the gradient of PQ is h goes towards not h, goes towards 0. Right, so I'll squeeze it in here. So the gradient of the tangent at P is the limit as h tends towards 0 of h plus 2x minus 2, which is simply,
0.
no,
Oh.
that's 0, 2x minus 2.
No.
So there's our gradient.
I feel like we're all going to get 14/7.
Now, yes,
With the coordinates, where you've like done expanding or whatever, I'm confused.
about what?
Me too, I think me too.
Is this bottom part, is that little part there the blue one?
When you like this,
Yep.
where did this x go when you put it on here?
Right, this x is this one.
Okay. I thought that x was the one from up here. I thought those x's were coming
Well,
from.
yeah, let me, it's this one here. It's this x.
We're doing.
It's that one, which yes is related to here. Because they're both the same, when you put that in there, it looks the same.
Okay.
Then to find the other point Q, we put x plus h in there.
Is that little bit of working out just over there the blue line?
This one here is the blue line, yes. And our blue line is our tangent.
They were actually teaching.
Also, how did you get that part?
Which one?
The H, the bracket, yeah, that
This
one.
one. So here's our function, x squared minus 2x. Taking this x value, and I put it in here, and I put it in here.
Okay, this way.
Alright,
There needs to be a medium.
so this little expression here is 2x minus 2 is the gradient of the tangent to the curve, anywhere on the curve. So if you have a particular x value, say 3, you would just substitute 3 in there to find the gradient. And it's also known as the derivative. So let me...
Are we doing another example?
Let's not rub that one off.
Not going to rub that one off. So also, because it's known as the gradient, the derivative, f dashed x, in this case will be 2x minus 2 for this function.
Is that how you answer it?
Is f dash x derivative?
The f dashed x is derivative, which also tells us the gradient. Of the tangent. Alright, so those two things are connected. Yes?
So the derivative tells us.
Derivative tells us the gradient. Alright? Of the tangent. Because that's what I did here. I gradient, 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 get closer to this gradient. This process here is called differentiation by first principles.
So what is the use of the tangent? Why do you
Well, because we want to accurately know what the gradient of the curve is at some point. So it helps us accurately know.
How do you have a gradient of a curve?
Well, it depends on where your tangent is.
So is there a different?
Oh, heaps of stuff.
So for every
Will it be
different
used in
point, there's a different.
Every different point, there's a different tangent, isn't it? And that tangent has a different gradient. And this will allow us to figure out what it is. So if x equals 0 here, the gradient of that tangent, put 0 in there,
Minus two.
gradient's minus 2.
Right.
Over here at 2, put 2 in here, 2 2's are 4, minus 2's 2.
Okay, not too bad.
See?
Can you just like rehash
With the
that?
correct name.
Alright, I'll go
One to one.
through the,
Where's the answer?
where's the answer?
Like
No,
which one is the answer?
right, which one is the answer? This one.
To expect it.
Yep. That's,
With an F in it?
yep.
Oh, thank
Alright.
God.
Zeke, more information. Cameron.
No.
Just quickly, with the very end, the bottom left corner, what you've done working out there, what does it say? It says M something.
Oh, gradient of tangent at P
Word.
is the limit as h tends to 0 of the tangent between PQ, which was this one here. So as we bring Q closer and closer, this gets smaller and smaller. And when it goes towards 0, what's it go towards? Well, this bit goes towards 0. We're just left with that. All right. The good news, though, people, is that there will be a pattern, and you don't have to do this derivative by first principles all the time. Once we figure out what the pattern is.
Study skills thing.
That's on. That's on.
All right.
That's
I'm going to actually do study.
That's the study skills thing's full section today.
Oh my God.
It's compulsory.
Yeah,
Oh my God.
Yeah, she's literally gonna. She's literally
I'm
gonna
going
put an
home
announcement.
to check now.
And she's gonna mark that. She'll have like a marking
I have
yellow
to go to
roll. So
the
we don't know if she's already set you up.
I was the one.
All right. Rubbing this off. One more example.
Put on the bottom half.
Can I take a picture?
Yeah, we do. One more
If you
example.
leave the bottom half
One
from
more. I would like one more example.
You're just gonna have to piece together the top.
Can we please not do
You cry.
Just from before, because I'm with Adrian and I are late.
I am
Yeah.
going to.
Wait, is that like that will work for everything?
That will work for everything.
So
Everything.
guys. So
I
it doesn't
think
get
ours-
harder than that.
Okay.
Doesn't get harder than that. In fact, it's going to get a couple of lessons time. It's going to get easier.
I meant in this chapter.
In this chapter, no, it doesn't get harder than that.
So you won't get like
This is the
2x take 3x squared take 2 take that. Yeah, I'm not doing it.
You could, Lara, yes, but we'll have another way of doing it.
Is there anything harder than 12, or is this just the hardest thing we'll ever do?
All right, rubbing the rest of it off. One example.
Oh, leave that little, just leave that little square.
I've got to use 12 from with words of
All right, so let me just write a quick note before that. So the derivative of function, so
Yeah, no, I had to flip over twice.
look at that pen's run out.
Wait, is this another question?
No, it's just no.
Is this just a summary?
Yes, summary.
Relief.
Right, just a summary. The derivative of a function fx is that, and I've also put that it tells us the gradient of the tangent. All right, so one more example.
My favourite.
x cubed squared.
Why would I ever need this equation? I don't really want to buy an expensive everything, so it's just second hand, so $100.
I'm just gonna drop this. I'm just gonna drop this.
Isn't that the same question?
Yeah, same question.
Passive.
I'm just gonna jump out of school because that's not how life works. Miles will be gone. He's retiring.
How old is Mr. Miles?
Well, who's teaching now? Mr. Lake's gone. Mr. Miles. And when he's gone, he's gonna.
It'll be like Miss Mascus or something.
He'll be top this year.
Do teach physics.
And you're not retiring next year?
I haven't won that slot yet, so you know, I'm
Yeah.
still here.
How old are you, Mr. Sam?
21.
Thanks, Lara. You're my new best friend.
Come on, buddy.
18.
Come on.
All right.
Wow.
So when it talks about differentiation by first principles, this is what we use.
Just give him a mud.
So we do the same thing as we did. So limit as h tends to 0.
Yes.
So now we put x plus h into here.
What, like 36 minus 2?
So 2 minus, so we're replacing the x by x plus h. And we're squaring it. And from that, we're taking away
Yes.
the function when it has x in it. So we're taking away 2 minus
0
x squared.
x minus 39.
And that's on h. The next step, expand this bracket and this one. So 2 minus, and that will be x squared plus 2xh plus h squared minus 2 plus x squared all over h. Oops, I forgot. And you'll get marks taken off if you don't remember to keep your limit thing in. So you keep your limit thing in until you actually substitute h equals 0. So I'll keep that there. All right, next line down. Limit as h tends to 0, 2 minus x squared minus 2xh minus h squared minus 2 plus x squared all over h. There should be some cancelling. There will always be some cancelling. And it will always be things without h, so that's going to cancel with that. This is going to cancel with this. Right, that will always be the case. Should always be the case. If it's not, you've made a mistake. What do you then notice about the top? I'm going to do 2 steps in one here.
There was fx equals 2 minus x squared. Yeah. Bracket, so we put
All right, so if I take h out as a common factor, I've got minus 2x minus h all over h. Got some more cancelling.
You got a different answer than last time.
Well, it's a different function. All right, so the limit
Oh, scribble that.
as h tends to 0 minus 2x minus h. When h is 0, what are we left with?
0.
No, 2x.
No.
We want some
Negative 2x.
what the bollocks?
All right, so that's the differentiation by first principles.
Do not rub that off.
I'm not rubbing that off.
Do it. I dare you.
Zeke, I'll come and see you, Zeke. You can go to the lavatory, and the rest of us are going to be there for everybody to hear. Exercise 17A. Right. So there is patterns, all right? So there is patterns, and we will have a look at what those patterns are probably tomorrow.
Can we have a break?
Isn't coming back now. Oh shit, I thought it was